Hi, my name is Kevin Shavinsky. I'm the co-founder and CEO of Modulos. At Modulos, we're building a data-centric AI platform, which helps you make best use of your data so that you can build trustworthy AI applications. One area where trustworthy AI applications, of course, is really, really important is in financial services. So that's why today I'm here with our financial services expert, Elena Maran.
Hi, everybody.
So today, Elena is going to walk us through an example of a use case in financial services. So from your experience in banking, what kind of use case do you think has a lot of value for using AI?
Wow, Kevin, what a question. There are several applications within the financial services that can benefit from the use of AI, in that artificial intelligence allows for the creation of new business models that are more customer-centric and data-driven. And this really spans across all business units, be it private banking, corporate banking, commercial banking, or retail banking. But hey, if I have to pick one single use case, I would go for credit risk management, which is an area I'm very familiar with, and it's within my very field of expertise.
So there are some upsides to using AI in a use case like credit risk, but there are also challenges and there are also problems. So what do you see as the main challenges?
Well, all the main challenges go back to one single factor, which is data quality. Data in a bank come from different sources, different systems. There are often missing informations, missing values, outliers, and whatever you can imagine. And even if we think of a data set that has been completely cleaned in a pre-processing phase, well, there are still questions that can arise around: are we using AI in an ethical and fair manner? Is the outcome of our credit risk model fair and unbiased towards different protected categories?
Right, because the raw data, the data that the bank collected is essentially the accumulation of all the human biases and misjudgments and errors that went into past decisions. And so if you just build an AI model trained on those data, they're just going to encode those. So it seems obvious maybe from an ethical perspective why it's important to build a fair model, but maybe there are wider implications for why you should do so.
Yeah, well, in general, taking into account the ethical aspect is very important for our financial institutions. There are legal liability risks, commercial risk, and reputational risk involved with taking biased and unethical decision in credit risk modeling. But allow me here to open a brief parenthesis, because it's important to point out how the upcoming EU AI Act, which is the broader effort to regulate artificial intelligence in Europe, will really require for this type of application to be fair. One of the requirements that the EU AI Act really puts forward for this so-called AI high-risk system, in which credit risk really falls in, is for the data to be quality data, free of errors and complete, for AI applications to be fair, accurate, and robust, for traceability and transparency to be involved in the process. So, of course, all the consideration around the ethicality and the fairness of your model are very important for banks, and even more now that soon the act will be passed into law.
So if you start with that dirty, biased, unfair data, that's the accumulation of past history, how would you go about taking that data and make a fair model and therefore try and be more in line with those future regulatory requirements? Like, how would you practically do it?
Well, let me show you a practical use case that I have analyzed. So Here we are trying to assess whether a prospect of an existing client of a bank is eligible or not for a personal loan. In other words, whether it is an acceptable or unacceptable credit risk for the bank. And here my objective is to develop a fair model to assess the loan eligibility, which minimizes the bias relative to some protected attributes. In this specific case, I consider gender as my attribute. And let me show how my data look like. So the data set was composed of 4,000 observations for which I knew whether the client, after the loan disbursement, had defaulted or not. So we can see here the historical credit process of the bank was surely not perfect because we lent money to individuals that afterwards had defaulted. But this is precious information on which I can build a model that has the required level of accuracy to make my credit process more robust and data-driven, but it is also fair according to the protected attribute of gender. So in this data set, I had some personal attribute, including those protected attributes of sex, age, and marital status. I had information on the past credit history and the relationship with the bank. So if the client had other credit exposure, what was the repayment industry, history, how long the clients had been with the bank. And then I had some specific details about the loan, including the amount, the purpose, the existence of potential credit mitigants. So for example, whether there was a guarantor or not. But let's dive deeper into the dataset composition. Wow, this is like unbalanced under so many layers. The most evident, if you wish, imbalance is the relative proportion between male and female observation, with 90% of my dataset being composed by male observation and only 10% by female. But we can dig deeper and find out that also the risk distribution of risk is unbalanced across genders. 70% of the total of the male population is acceptable risk, and only 45% of female are good credit risk. Even further, the allocation of risk is unbalanced across age buckets, with the most evident imbalance being in the bucket 18 to 30 for the women gender.
So this is a reflection of what we refer to back. This is what those individuals making decisions to accept or reject a mortgage application or a credit card application by basically saying, like, I like you, or I don't like you, or in my experience, people like you are just bad credit risks. So we see that imprinted here on the data, and we see that it's not fair and it's unbalanced. And so now you have two business objectives here, right? So on the one hand, right, a bank wants to make money, so they want to make as many good loans as possible and minimize as many bad loans as possible. But at the same time, they want to do so in a way that's fair, so that you don't replicate this bias that's evident here, right?
Right, Kevin. But the question comes, how do I go about it? Like, what do I do on this unbalanced data set? Where do I start from? And do I have a way to pre-process my data, which will make the outcome of my model fairer? So I can follow my initial intuition and say, well, the biggest imbalance here is in the relative proportion of male versus female, and try to see whether by deleting randomly some of the male observations within my data set, the fairness of my model would improve or not. Or I have the luck of having at my disposal a Modulos Data-Centric AI platform, and I can be guided by Modulos recommendation on what are the records within this data set that have the most negative impact on the performance, and in this case, by performance, I mean fairness, of my credit risk model. So let's see what happens when I follow intuition or when I use the platform. So on the chart, on the left-hand side, we have the results about using our system recommendation, our so-called data quality management, or DQM. On the right-hand side, we have the results where I randomly deleted some observation relative to male individual following my initial intuition. And the results, I must say, they are striking. So let me make a few observations about notation here. The fairness score, which you read along the blue line, is read in a way that lower numbers represent a better, higher fairness level, right? The accuracy is denoted by the orange line. So if you observation, our DQM achieves a much better and consistent fairness score. Yes, we have an expected accuracy degradation because there's a trade-off between accuracy and fairness. But after an initial not so massive drop, then the accuracy level is held almost constant. So the trade-off between accuracy and fairness is rather small, right? And let's compare it with the random deletion of record. What a disaster. So we end up with an even worse fairness score that we started with. And even the trade-off between fairness and accuracy is completely inconsistent.
So this is where you basically say, oh, maybe my model is unfair because I have mostly observations of men and very few observations of women. So maybe if I just remove some, because that's cheaper than getting more observations, maybe I hope my model will be fair. Or maybe if I try to generate some data, right, like then I just replicate what I have. Whereas with DQM, with our recommendation, basically says like these things have the most impact. So again, you could say either I add some more observations of this type, or I remove some of that type for maximum impact, both in terms of maximizing the accuracy, of course, and minimizing the bias, getting the fairness as close to fair as possible. What's also interesting here is that, of course, you have a record now of what you did. So not only do you have a machine learning model where you have the code, which you can download off the platform, and all the parameters and everything that goes into it, but you have a record of what you did so that you would try and meet those goals, right? If somebody comes to the bank and says, I think I was discriminated against, you can go back to the record of your experiments to say, yeah, but actually we did our very best to build an unbiased model here, and we actually show how and why we did it. And we have a record of the person who did it, right? In this case, of the choices you made and the decisions you made to make it as fair as possible. So this also backs up the case of the bank.
Yeah, absolutely, Kevin, you're spot on. And let me show you what's behind the results, right? Because if I'm in front of an auditor and I'm questioned about the fairness of my model, and I had just randomly deleted some male individuals where I don't have really a story to show, I end up with a worse fairness that I started with. Following our system recommendation, I can prove that I undertook on my starting data all the possible actions that are required to achieve my desired level of fairness. And fundamentally, how the data sets look like after I make a few iterations in a random pre-processing fashion or following our DQM methodology are fundamentally different. Look at this. When I randomly delete respectively 1,000 or 2,000 records in a random manner or following our DQM, well, we can see that in the random process, yes, I've increased the relative proportion of female individuals in my data set but have done absolutely nothing to rebalance the risk distribution across gender. We can see, on the contrary, following our methodology, the risk distribution is completely different, in a sense that I increased fundamentally the numbers of female observations that are good credits. And even counterintuitively, I reduced the relative amounts of female individuals in the overall population. And the same goes for the distribution of risk across age buckets. The random preprocessing of data would have done absolutely nothing in order to reduce the gap in risk distribution that is particularly evident between the 18 to 30 and the 30 to 40 age bucket. Whereas DQM does very well this rebalancing there.
So basically, if we translate the machine learning recommendations into what it means in the real world, which is what you as a person building such a credit scoring system would do, you realize that actually what you needed was more women with good credit.
Correct, pretty much so. And I needed more women with good credit, and I needed to focus on this particular aspect to make my model fairer. But this is not necessarily something that I would have been able to see just by looking at the composition of the data, even if I had the idea that women as a good credit were underrepresented in my data sample. I could have had no insight on how this would affect the performance of my model.
Right. So DQM basically gave you the guidance in which direction to go. You interpreted that guidance based on what you knew about the data, and then you were able to close in on both of your business goals, which were an accurate credit decision model and one that's fair. And you basically achieved both goals in some balance in this use case.
That is true. But now that we talked a lot about credit risk today, well, Kevin, I would like you to tell me what are your takeaway from this conversation, and if you could put them in context of what we do at Modulos with Data-Centric AI.
Yeah, so coming from the machine learning data science side, it's of course really cool to see how the sometimes very abstract tools that we build have a real world impact, how the recommendations we can give have a real impact to build better models, right? That's central to the data-centric AI philosophy. You should have good data rather than big data. And this is exactly what we saw in this use case. So first observation is it's very gratifying for me to see how the DQM system guided recommendations helped you achieve your goal and help you do that essentially with the existing data in a very short amount of time, and without having to involve huge new data collection or curation projects. You also did this with basically our low-code platform, right? So you can build the whole business case and build it in a way that creates an audit trail in such a way that the resulting model has a high degree of trustworthiness than if you just did it by training some model on the existing data. And so from our perspective, that is one of the things that's, again, super exciting to see, is that this can help simplify compliance with these upcoming regulations. So you mentioned the EU AI Act. I mean, most countries around the world now have voluntary guidance for ethical and fair and trustworthy AI. And those are going to turn from suggestions to requirements very, very soon. So being able to provide business users with this ability to build trustworthy models with the right audit trail, of course, is super cool to see. What was also very interesting to see is how you made that trade-off between the accuracy and the fairness, because of course it is a trade-off, and that's a business decision. That's not something that we can automate and solve automatically. That's a decision that a human needs to make, and I think it's actually very important that a human makes that call. And it was also interesting to see how what you thought was the intuitive logic of what you should do to your data set, that wasn't helpful at all, that it was something very, very different. And of course, that DQM gave you the guidance that helped you solve this problem.
Absolutely, Kevin. It was very exciting and helpful to use the platform to solve this particular use case.
So thank you very much, Elena. Thank you very much, all of you, for joining us for this video. And if you want to give Modulos a try yourself, head to modulos.ai and request your demo.
Perfect. Bye, everybody.
Bye-bye.